This is like no different from humans, where you see a bunch of SMEs come together and solve for a business problem. You replace SMEs with agents. That's the world where we're heading into, where a bunch of these subject matter expert agents come together and solve for a particular problem. And they need to collaborate when they come together. To us, the Internet of Agents is that platform. It's an open, interoperable, quantum safe platform for agent to agent collaboration.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Vijoy Pandey. Vijoy is a Senior Vice President and General Manager of Outshift by Cisco. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Vijoy, welcome to the podcast.
It's amazing to be here. Thank you, Sam.
I'm super excited for our conversation. We're going to be digging into one of my favorite topics nowadays, agents, and in particular, how agents work best together in an enterprise. Before we dive in, I'd love to have you share a little bit about your background.
I am the SVP GM of Outshift by Cisco. And think of Outshift as an internal incubator within Cisco. So we are building businesses for Cisco in adjacent spaces. So if you think about Cisco, you think of a networking giant, you think of security, you think of collaboration and observability, especially after our acquisition of Splunk. And if you think about Outshift, we are looking at what adjacencies can Cisco get into, both in terms of space and time. So space is, yes, we are going after, let's say, a persona X, let's say the network engineer. Is there an adjacent persona that we can build products around and then go after that market? In time, it's more around handling risk. So if you think about technologies that might have risk involved with it, like quantum, you might have markets where the tech is proven, but the market is still forming. Agents is a good example. So we look at some of those problems where there is a little bit of technology risk, a little bit of market risk, and then we enter that space and we see ourselves as reducing risk for Cisco when they want to enter a particular market. And the way we are structured is actually pretty interesting as well. We are structured as a bunch of startups inside of Cisco. So we have everything from ideation to engineering to product to marketing, customer support, and business development all rolled into one. Because when you enter a new market, it's not just about building product, it's the go to market situation that easily complicates itself. And that is the hardest challenge to solve.
So talk a little bit about Cisco's interest in agents. Why is this an interesting opportunity?
It's actually a multifold problem statement. We all know that the world is going to be very agent forward, where you'll have a collection or an ensemble of agents coming together and solving a big business need. And so this is like no different from humans, where you see a bunch of SMEs come together and solve for a business problem. And you replace SMEs with agents. That's the world where we're heading into, where a bunch of these subject matter expert agents come together and solve for a particular problem. And they need to collaborate when they come together and solve this problem. So, where is that collaboration platform? And so, to us, the Internet of Agents is that platform. It's an open, interoperable, quantum safe platform for agent to agent collaboration. So that's the problem that we're going after through Internet of Agents. And it's a forward looking problem statement. And it helps in the products that we build within Cisco, but it also helps as a collaboration platform for all agents that exist out there.
And when you describe it as a problem statement, that's a bit abstract, but you've announced an open source project called Agntcy that is designed to make these ideas more concrete. Can you talk a little bit about Agntcy and what you're trying to do there?
Think of Agency as the open source version for Internet of Agents. And so if you think about Internet of Agents, again, the problem that we're trying to solve is how do you bring disparate agents from different vendors with different capabilities, with different subject matter expertise to come together to solve for a business need. So let's start with a concrete problem. 2 years ago, if you were to stand up a sales funnel pipeline software stack for all of your for the entirety of a sales organization, you would bring in Salesforce, you would bring in, let's say, identity for Microsoft, you would bring in cloud native security and security platforms from Cisco. I'm being biased here. You would bring in employee databases from Workday, and that'll give you an idea of which identity gets authorized to do what. And you would go through a bunch of clicks, connect all of these platforms together, and voila, out would pop a portal for you to look at sales funnels and sales pipelines in your large enterprise. And I'm not going into the complexities of now setting it up, deploying it, scaling it, managing it, but there's an entire pipeline. I'm not minimizing the work, the pain that are
There was some magic in there somewhere.
there is a lot of magic and there's a lot of toil, I would say, our IT operations teams actually go through. But it was all front ended through a SaaS or multiple SaaS platforms and a ton of code that somebody would write within the operations team to make it all happen, to make the magic happen. What's happening now, for good or bad, and I believe it's all good, but we can have a discussion, is that all of these platforms are becoming agentic in nature. So Salesforce, Agentforce, Workday is becoming agentic in nature. They have a bunch of agents. ServiceNow, which is a ticketing platform that is actually driving the workflows behind this, is completely agentic in nature or moving towards that. Microsoft Identity, that's becoming agentic. Cisco security is becoming agentic in nature. All of the cloud native platforms are becoming agentic in nature. So you have all of these platforms that were point and click, write some blue code, walk away, you're done. They're all becoming, here's an NLP interface, here's an agentic backend. How do you connect these things to deploy the same thing, which is a simple sales funnel application for your large enterprise? So you have all of these disparate agentic work components, which are subject matter experts in their own domains, but they all need to come together. They're all by different vendors. They speak different languages. I mean, one thing may not seem the same to the other. So semantically, they're different. They have all been built on different frameworks. So some might have used LangChain as a framework. Some might have used Llama Index as a framework. Some might have been built on Bedrock or Q on Amazon. They've all they might reside on different clouds, and they all need to be stitched together in an identity and security and guardrail framework that is very enterprise centric. That is, in our case, when we deploy this, it needs to fit into the Cisco security paradigm and the Cisco workflows and the Cisco scaling and cloud paradigm. And so, how do you do this? The platform for that is exactly what Internet of Agents is trying to accomplish. And so, if you think about the workflow, we break it down into 4 steps.
Before we even go there, I want to interject. You started this by saying, for better or for worse, this is the direction that we're going. And as you described this use case of got a bunch of SaaS systems and you're trying to integrate them, the way that you would typically do that, you mentioned glue code, integration tools, and thinking about replacing that with agentic systems. In many ways, we're taking kind of well-defined interfaces and replacing them with undefined, noisy, and probabilistic interfaces, which doesn't necessarily seem like it's a pure win. The wins, I guess, are potentially a degree of agility, and if you can eliminate the need to build that glue code, that's a win. But given the current state of agentic systems, there are some drawbacks for sure. So, talk a little bit about how you see all this playing out and like how organizations will trade the determinism of traditional integration versus the potential noisy messiness of agentic style integration.
You hit the problem right on the head here, Sam. So I think As with every step function change, and I believe we are at a step function change where we're going from deterministic computing to probabilistic computing, or a combination of deterministic and probabilistic computing. So that's the big step function change, which means that we're moving from an abstraction that was cloud computing to an abstraction that is agentic computing. And it's a higher level of abstraction. And every time a higher layer of abstraction comes in, there is pain associated with it. We've seen this time and
It
again.
doesn't seem like that now that we're looking at cloud in the quote rearview mirror, right?
That's right.
But there was a lot of pain.
I mean, imagine what people did when we started out, right? I was like, I like this thing in my environment, and I'm just going to replicate this thing on the cloud
Yeah.
because this is what I'm
Well,
familiar
and
with.
and we used to talk about server huggers, folks who didn't even want to let their stuff go to the
That's
cloud.
right. And it's like, I like this pet that I have, and I like really, I've named it, I've groomed it, I've
Pets
had,
versus cattle analogy
yes,
for
exactly.
yep,
And so,
yep.
so you have to go through that pain, and we are not done with that either. I mean, we are very, I mean, even with the cloud transformation, it's like, how do you reorganize, restructure your code so that it's cloud native in nature? That's not done yet. In fact, we've given up on some areas and said, this is going to be a monolith. Don't touch it. I'm good. Whereas in some other cases, we're like, okay, let's break it down and make it more scale out and scalable. So that pain we're still in the middle of, and we are starting on this new pain, which is take everything deterministic and make it agentic. The step function here is you are dealing with deterministic APIs, and then you threw in human toil on top of that to make things all work. Because in the end, a human is making decisions, a human is taking actions, a human is uh, reading and making sense of some data or dashboards. And all of those things, what we're saying is we have an agentic workflow and we have LLMs and foundation models and code around it that actually can help you as humans make some of those or offload some of those decisions and data parsing and code generation and document generation to an agentic system so that you don't have to do it. Because so what we are doing is actually moving that level of abstraction one level higher, where humans don't have to do a bunch of work that they are somehow used to doing and somehow have believed that it's the thing that we call work and we enjoy. But we need to actually, agents are good enough that they can offload some of that work from you as a human. And that has not been possible in deterministic systems. So, yes, whereas there's going to be pain to make it all happen, what will allow humans to do is offload some of that work to agents, and then humans can do higher abstraction work and higher value work. And that's the pain that we have to go through. So, I'll give you a quick example here, if you're okay with it. So, we built this multi agent system called Jarvis. And Jarvis, there are many, many projects called Jarvis. So it's, everybody loves Iron Man and everybody loves the Marvel characters. So in our case, Jarvis is an SRE Jarvis. So it's SRE Jarvis. So let's call it SRE Jarvis.
SRE as in site reliability engineer.
Thank you. Yes.
So
So
DevOps kind of
DevOps kind of engineer. So it's a site reliability engineer Jarvis in the cloud native space. And so what it's trying to do is trying to look at everything that Outshift does. So that's how we started out. Everything that Outshift does and where humans were involved. And can we start replacing some of those outcomes with Jarvis? And so on the surface, Jarvis is one interface. And when I say it's one interface, it's actually 5+ user interfaces. You can access Jarvis through a WebEx chat. In due time, it'll become Slack as well, but some text interface. You can access it through Backstage, which is a pretty well-known interface orchestration engine in the cloud native world, which is open source, by the way. You can access Jarvis through a VS Code plugin. so a codified plugin. You can access it through Jira or CLI. So it's got a bunch of user interface, but you interface with Jarvis. But Jarvis itself is 20 agents behind the scenes. And the 20 agents are doing all sorts of tool and data calling. So they're doing RAG tooling, they're doing live calling to Kubernetes, they're doing tool calling to PagerDuty, they're doing tool calling to AWS, Backstage, or Commodore, which is another open source project in the cloud native world. So they're doing a whole bunch of tool calling at the back end. They're interacting with Jira. They're doing CI/CD pipelines. They're setting up EC2 dev instances. They're doing plumbing to access LLMs. They're writing code. So they're writing Kubernetes code. They're writing sandbox code for VMs as well as Docker images and so on. And the outcome for all of this. So whoop-de-doo. What's the big deal? Right? Are these just engineers gone wild? I mean, is this? So here's what we've managed to achieve. We used to have a support desk where 3 engineers or SREs used to support that desk continuously. And all of that is now being handled by Jarvis. So 3 engineers worth of daily toil is now handled by Jarvis. And this is at Outshift scale, which is not Cisco scale. So if you start looking at Cisco scale, which we're doing right now, we're deploying it in various Cisco teams. I'll have better numbers for you, but it's going to be 10x, 100x larger than this. Now you're looking at, so now think about, so that's one outcome. The other thing we managed to do is almost 30% of tasks that engineers would do, not just SRE, but consumers of the software SRE platform, we've taken that from a day to minutes.
And the kinds of tasks that we're talking about here are engineer needs to deploy something to a Kubernetes cluster
Or set up a new LLM for usage, or create an EC2 instance, for example, or uh, like plug in a whole bunch of RAG databases into the pipeline that we have. So any cloud task that you can think of, set up a new VM or set up new identities, and so or any new task you can think of, you would need SRE engineers and software developers to come together, go through a workflow cycle, and it would take a day or more than a day to set these things up. And now it's literally minutes for 30% of the tasks. So not everything, but it's 30% of the tasks. And we're walking through those workflows. The query responses, because engineers might have queries or questions on how does this work or is this running? Those things have gone to seconds because those things truly should not take any time. Tell me what Docker images are running in this cloud instance. That should be like, voila. I mean, I should not even look at a dashboard and try to parse that dashboard. It's like, here's an NLP request. I should just spit that out for you. So that seconds, uh, the support desk has gone from 3 engineers to Jarvis, and 30% of tasks have been eliminated from human interaction and is completely agentified. So this is the so what. And we're trying to do this again in a pretty different environment with Swisscom, who's our uh, basically our one of our biggest service providers that we work with. And so we're trying to figure out how we can fast track their network config deployment and debugging pipeline using a multi-agent workflow. So these are some of the examples that we've been working on. There are many, many, many more, where the Internet of Agents is the platform that we're leveraging, but these are real world use cases that you all come across every day.
Yeah, so when you talk about this as a platform, what is the platform providing, or conversely, like what is needed, when you're deploying out an agentic internet of agents, let's call it. Uh, what do those agents need that needs to be provided by some platform?
So if you think about the Internet of Agents as the way the platform where all these agents come together and collaborate. And the agency is the open source manifestation of iterative agents. We think about the entire problem of agent to agent collaboration in 4 phases. The first one is discovery and identity, where you need to discover the agents that you need to bring together, their capabilities, their reputation, their uptime, the way the languages that they speak, how long have they been available. You need to look at all of those things to then narrow down on the agents that you want to bring in to solve for your business need. Along with that, you need to assign identity to those agents because agents are like humans, so they have human capabilities and characteristics, but they operate at machine speed and scale. And that makes them a pretty dangerous object from the identity perspective because you are giving them agency to act on their behalf, to do things on your behalf. So ensuring that identity is taken care of is also a big problem. So discovery and identity is phase one. And once you settled on those things, you want to compose them in a workflow. So all of these 20 agents, like we talked about in Jarvis, they need to come together in a workflow to solve for, let's say, deploying a workflow in EC2. And so how do you connect them, stitch them together in a workflow? That composability is phase two. Once you have that composability done, you need to deploy it on that cloud native infrastructure or on-prem, doesn't matter. So deployment is phase three, which is where you're also scaling out these things. And then finally, you have to observe and evaluate. So in the cloud native world, we stuck with observability. In the agentic world, we need to also figure out whether agents are doing what they said they were about to do. So are you really doing what you said you were about to do? Not just on a per agent basis, but especially when you have 20 of these things from different vendors coming together and collaborating. Because believe me, there's going to be finger pointing.
So this is a governance layer in an enterprise context that would live within that phase.
There'll be governance in that phase as well. You're right. But there's also evaluation where you said you had 90% accuracy. But what I'm seeing is only 60% accuracy. And that's per agent. But if you have 10 of these, we thought that a 10 of these would give me 90% accuracy. Each one of them is giving me 95% accuracy. But when you stitch them together, there's a dramatic drop off, and you might not get your 90% accuracy in a collection or an ensemble of agents because they're all probabilistic in nature. So, evaluation of the outcomes from agentic workflow is a big deal. So that's the fourth phase. And so tying all of these things together is what will give you the outcomes that you desire.
Okay. So a couple of questions to help me narrow in on, what exactly we're talking about here. So the first is you said that agency or this internet of agents is where the agents come to collaborate. I guess I'm forming a visual picture of that. Like if I have Salesforce, the Salesforce agent is, on Salesforce's infrastructure somewhere. The Workday agent is on Workday's infrastructure somewhere. I've got some agents running on my infrastructure. What does it mean for them to come to a central place to collaborate? Is this like, should I be thinking more like a communications hub? Or should I be thinking of it in a different way?
Yeah, so that is exactly the problem statement that the Internet of Agents and Agency is solving, which is all of these agents that you just described, and with the use case that we were referring to earlier, setting up a sales funnel pipeline in a large enterprise. Yes, there'll be a Salesforce agent running on their cloud with their code, with the frameworks that they've used to develop. Similarly with ServiceNow, Workday, Cisco, Microsoft. But the the poor IT admin and the poor SRE within large enterprises is trying to stitch all these things together in a cohesive way. And so how do you do this? So the analogy I would draw is think about the original internet. And so when you would want all of these servers and all of these web servers scattered across the globe, belonging to different entities to come together and talk to each other, how would you do that? The first thing you would do in the discovery phase is you would do a DNS request and say, you said pets.com. Where is that pets.com? And identity or verification is it's signed by VeriSign. And so I trust that pets.com is a valid endpoint to talk to. And so the equivalent of that in agency would be there's an agent directory. And you would go there and say, I really need an agent that does sales funnel setups. Uh, and who is it from? Oh, it's from Salesforce. Where does it reside? Oh, the endpoint is sitting on Salesforce's cloud. Is it reputable? Yes, it is because it's Salesforce and I trust Salesforce. So, and you would do that with ServiceNow and you would do that with Workday. But then there are other agents that you might need in the picture. Agents that Cisco, if you're deploying it within Cisco as an enterprise, like our IT organization or our engineers might be writing agents as well. So where do I find them? Maybe they are code and they're sitting within Team X or Team Y within Cisco. Or you might be trying out a new startup, which might not be as reputable. So this startup might come in and say, here, these are guardrails that are the next best things since sliced bread for your agentic workflow, but I'm net new and I'm a 10% company. So how do you discover those things, experiment with those things, bring them in this workflow? So the DNS equivalent in the Internet of Agents and agency is the agent directory. And there is identity associated with it as well to ensure that there is trust behind those agents. So that's step one. And you leave all of these things sitting where they are, right? So you're not really bringing them together physically. They're endpoints sitting somewhere. And then you get into the next few phases, which is composability and deployment and evaluation.
Yeah, and presumably there's a service associated with each of those as well, or so one or more.
That's right. So if you, to your question earlier, now you've connected all of these things in a workflow for a sales funnel application. ServiceNow is speaking language X because even though they might all be natural language English, for example, or French, doesn't matter. All of these agents may not mean the same things when they say, this is my outcome, or uh, this is the accuracy with which I'm giving you this outcome. So the one thing that has happened when we've moved from deterministic computing to probabilistic computing is that instead of your APIs, quote unquote, being deterministic in nature, your APIs are now all probabilistic in nature, both from the intent perspective, which is show me the best X. What is best? It is up to interpretation. And the response, the outcome also is this is the best X with 90% confidence. 90% for Salesforce or Cisco or Microsoft could be very different. So, how do we build a framework where all of these outcomes and inputs in probabilistic manner can have a common understanding? And so, there is a communication layer that needs to be built to handle this. And so, that's where the communication protocols come in, both from the semantic perspective, which is what does best mean? What does 90% mean? But also from the syntactic perspective, which is where the world is going crazy right now, which is A2A and MCP and ACP. That's the syntactic layer, which is does the noun come before the verb or the verb come after before the noun? That's what we're dealing with right now. But nobody is talking about the semantic layer, which is what does best mean? What does 90% mean? So that's the communication layer. And then think about the actual transport. That changes dramatically as well. And this is where Cisco steps in and is really awesome at it. because we're a networking company, which is all of these agents are now communicating with each other with massive state exchanges. They're all multimodal in nature. It's video, it's audio, and you expect real time behavior because guess what? Agents are supposed to be like humans, right? Operating at machine speed and scale. So, how can you have audio, video, text, images at machine speed and scale being done efficiently at real time? That is an unsolved problem that we're trying to solve through agency and Internet of Agents as well.
So are you suggesting with that, and now like I've got like three questions behind this, but are you suggesting with that you are envisioning or exploring post HTTP protocol layer or transport for these kinds of agentic applications? Like I think most of us think, okay, video, images, audio, we just need bigger pipes. But bigger pipes is, a relatively solved problem. You just, pay Cisco or whoever more money, get better cards, blah, blah, blah. But it sounds like you're talking about more like protocol transport level things.
You're reading my mind here, Sam. So it's you're right. I mean, typically what you would think is bigger pipes is better outcomes. And yes, you do need bigger pipes. I mean, without bigger pipes, you can't push more data and more traffic through your pipe. But the other aspect here is, and the analogy again, if you go back a few years or couple of decades, we went from telephony, which was a completely different network, and data internet, which was a completely different network, to merging those two together. Converged networks, where you had IP based telephony. And the world has changed. I mean, everything that you use today, whether it's FaceTime, is all IP based telephony at this point, right? It was not just bigger pipes. There was a lot on the protocol layer that had to be done to enable real time experiences on the internet. So, in the cloud native world, HTTPS became the new transport, gRPC and the like became the API of choice, and service meshes and service directories became somewhat of a routing layer.
Well, and now with all of the audio agents, we're starting to see more like WebRTC and RTMP and all this stuff like popping up all over the place.
Right. And so to me, cloud actually pushed the transport and routing layer to HTTPS and layer 7. And that's where applications sat, right? And now with agents, I believe we're adding two more layers. We're adding the semantic communication layer and the syntactic communication layer. And so we're adding two more layers where applications will now sit and they need to talk to each other semantically with the right syntax in place. And that needs to be that needs to handle multimodal state, that needs to handle real-time behavior, that needs to handle security. Please, oh God, please, let's make sure that security is quantum safe right from the get-go, because quantum is not that far off, and especially breaking security in the quantum domain is not that far off. And so let's make sure that we don't have a migration problem again. So let's make sure that that semantic and syntactic layer of communication is quantum safe, real time, and handles multimodal state across many to many agents efficiently. So that's the layer that I think we are really excited about.
All right. So that it's kind of a nice segue to the next question on the stack here, which is when you talked about that semantic interchange, and the example you used was the best X is and what does best mean? It made me also ask the question, what does X mean? And I thought about like, you know, maybe there's some role for like a MDM, master data management type of thing, like, person and this agent is customer and that agent. Like, is that something you're thinking about yet?
Yeah, so I think MDM is a good example. The other way we're thinking about this is, in some ways, it's an agentic problem itself, where what and it's a probabilistic problem as well. So what you're saying, Sam, and how I interpret it, and vice versa, is even in the human to human communication realm, is a very probabilistic problem statement. I mean, I cannot guarantee that I understood you, and therefore I will ask you. And there's a vector DB running in my head as well. It's a closest search that I do in my head, and that's how I come across as, yeah, maybe Sam means this. And so, in some ways, this semantic translation is a probabilistic, uh, agentified translation mechanism, because I don't think we can build a table per se of any to any for any agent in the world.
Part of how I'm taking what you're saying is that, perhaps this is an advantage of an agentic approach to information because, if you've got a bunch of records that are labeled person, 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 and, the other system is expecting customer, 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 you used to need to stand up an entire system to map those one to another. But an agent that kind of that has a knowledge of language can see that, oh, this person is probably customer and map those together. Modulo the probabilistic aspect of it.
The way, yeah, you hit it. I think the way to think about this is humans are inherently probabilistic. We thrive in chaos because that allows our creativity to unfold. And and that allows for better decision making. That allows for creating new things. And that allows for looking at problems in a different way. And so to me, we are unlocking new capabilities through software that were not available previously. And so instead of force fitting some of that to a deterministic model, let's keep that creative chaos alive because that's what humans excel at. Now, having said that, it is amazing if you abide by this philosophy as a consumer. So when I'm creating documents or when I'm creating videos or images and I'm dealing with ChatGPT all day long or Gemini, whoever, take your pick, this is amazing because I'm being creative. In enterprises, this is a little scary because
Right.
because you can't. I mean, even with humans, you have structure in place and you have guardrails in place and you have processes in place because of this very reason. Because humans are creative beings, which also translates to they are chaotic beings, and so how do you put guardrails in place so that humans are swimming within a swim lane? And so the way I think about this is let agents be a little creative. And right now, we are not there yet. We're still force fitting agents into deterministic workflows. But in the end, the way I see this play pan out is we'll have different modes of deployment of agents within enterprises. And so you'll start with very deterministic workflows where it's like, I know exactly which agent to plumb, stitch where, and I'm just going to deploy that graph as is because I don't trust anything below it. So agents are probabilistic, but my graph is deterministic, and the APIs and the tools that the agents are calling are deterministic. So it's a deterministic sandwich. And so then I'm comfortable. So that's where I stand. The deterministic sandwich is the mode of deployment. Then I start getting into, you know what? I'll throw some amount of semantic routing in the mix where instead of it being a fixed graph, there are points in the graph where a human can enter and say, you know what? Not here, but take the workflow there. So humans are making decisions in that graph and they can steer the communication from agent one to agent two to agent one to agent three instead. So that's semantically routed graphs. And so that's a little bit of more chaos being thrown in. The wild goal that we all have is the agent itself. There's a supervisor agent that itself figures out there's a set of agents. This is how I structure it for a business workflow A. and I'm just going to structure it or compose it on the fly. So self-forming agents. I think for that, within enterprises, we are a bit far out, but that's a good goal to have.
You talked a little bit about protocols in the context of syntax versus semantics. I want to dig into that more because I'm sure there are people listening to this that are saying, wait, A to A, MCP, like, where does this fit in? Is this a new competitor to all of those things? Riff on that a little bit more.
Yeah, so like I mentioned earlier, I mean, this is where the world is going wild, where what's the next protocol? And it's a very important piece, but it's just a piece of the entire puzzle. So you have discovery, you have identity, you have composability, you have three layers of communication: semantic, syntactic, the transport layer. Then you have security and observability. All of those things need to work in a very distributed way, just like the original internet, to make this vision happen of agent to agent collaboration. Now, in the middle layer, which is the communication layer, where I said the semantic, syntactic, transport, the syntactic layer is where A2A comes in, MCP comes in, agency has a protocol as well. It's called ACP. IBM has a protocol as well called ACP, which is a problem because now you have two protocols called ACP. But to me, this is let's get behind one or two. Let's not fight this battle. It doesn't make sense, right? So there are good parts to every proposal out there, to the two ACPs, to A2A, to MCP. Let's get behind converging all of this.
I get that. I guess where I'm wanting to go is a little bit like if I'm trying to understand this landscape, when I look at uh, A to A, like I hear them talking about, the reason why it is superior for agent to agent relative to MCP is because you have, these are stateful conversations and this protocol needs to handle state. And now you're talking about statefulness as like a thing that your platform needs to handle. Like how do we think about the differences between what a platform is providing and what a protocol is providing when there are a lot of overlapping requirements?
So that's a good deep dive there. So first and foremost, there are differences between A2A, MCP, because one is agent to agent. MCP, when it started out, it was agent or LLM to tool or
To
data
tool or
sources.
API, yeah.
Yeah. The problem is, or the good thing is, whichever you want to look at it, is that it's all a small matter of software. And so you can take MCP in the other
I've
direction.
had this argument so many times. It's
So
like
So it's like what we're really doing is we're saying there's syntactic and framework differences between LLMs, agents, tools, data sources. And that commonality needs to be handled somewhere. And so Anthropic and MCP started in one direction. They have an explicit roadmap that is going towards agent to agent as well. In fact, you need to look at agent to human and all of these other things as well in between. And A2A right now is in the A2A layer, but I don't have public information on where they will want to go next. So, but I mean, you can build extensions in any one of these to handle all kinds of use cases. But what you're doing here is handling the framework, the API and tooling complexity at the application layer. So this is something built with Llama Index talking to LangChain or Bedrock talking to LangChain, or something sitting on Google Cloud talking to somebody else outside, somebody talking to a RAG source somewhere in your environment. These are the kinds of problems that these sets of protocols solve. But in the end, they need to sit, I mean, the rubber needs to hit the road. So they need to sit on the cloud native infra, they need to sit on actual networking gear. They need to provide the SLOs that nobody's talking about right now. So everybody, the journey is too early. where you're saying, let me handle the app level problem, the agent level problem, but you're not looking at SLO guarantees. You're not looking at performance. You're not looking at efficiency. You're not looking at how it's all going to play out on the infrastructure that sits below. That's where the protocol that we call SLIM, and I can talk about that in a second, but it's a secure multi-agent real-time messaging layer. And so that's where this protocol bridges the agentic layer to the actual infrastructure layer. Because yes, you can do the framework or API level communication here at the agent layer, but how do you translate it to the performance, SLO, efficiency, security guarantees that you need from the network? So what we've done with that slim layer is that we've enabled A2A to leverage the SIM layer, and it automatically becomes secure, real time, multi agent to multi agent by default. We've enabled MCP to sit above the slim layer. So MCP becomes secure, multi agent, real time in nature. So we are taking all of those agent to agent layer protocols and making them, if you make it run over Slim, which is the transport layer, you get quantum safe security, you get many to many agent support, you get real time capabilities, and you get multimodal efficient state transitions by default. So it's the layered architecture that we all love and believe in, where let the agent to agent complexity happen at A2A MCP, but let the transport give you the guarantees that you need.
When you look at agency, there are, among the partners of folks like Crew AI, LangChain, Llama Index, is part of those relationships that they'll have adapters so that they can run Slim as the underlying protocol for those kind of communications?
So there are this. So that's it's a layered question. So right now, those four partners that you mentioned, they are all contributing to ACP. So ACP, A2A, MCP, that's the multi-framework to multi-framework collaboration. And then whether it's ACP, A2A, MCP, they have all been enabled on Slim, which provides the guarantees that you need from the
I
network
got
below.
it. So
S-
they're supporting these, protocol options,
Yes,
and
Slim
part
is a
of
Slim is a common transport layer for any agentic communication layer that you build. So think of Slim as the default TCP/IP or HTTPS for everything that is done at the agentic layer. And by the way, we're not reinventing the wheel here. So Slim is leveraging HTTPS and gRPC to make all of this happen, but it's adding these capabilities so that you get these capabilities of, again, real time, multimodal, many agent to many agent, and secure.
and so is uh do Anthropic and Google and the like, as stewards for MCP and A to A, et cetera, do they need to plug Slim in, or is it, a passive, swap some kind of way? Like, what's the mechanism for making MCP run, for example, on Slim as opposed to native HTTP as transport or whatever they're using? I think they also use GRCP,
Yeah, so I think
gRPC.
gRPC.
Yeah.
So right now everybody's using gRPC, but gRPC does not provide you these four things that I just talked about. And so what you do is there are two lines that you put in your, let's say, Python code in the agent that you're building or the workflow that you're building between agents as well. The two lines are, the first line is you pick your agent to agent communication layer. So you can say A2A, ACP, MCP when it gets there, whatever that needs to be. So that's line number one. Line number two is pick Slim. So with those two lines, you've handled your syntactic layer of communication between agents and the transport layer that you want to use, and you're good to go. So it's really straightforward to use.
And in terms of the persona that is using agency, is this a person who is this more of an IT DevOps kind of person, or is this an engineer who's building a system? Like, is it even app focused or system focused? Like, who do you see using it?
Sam, this is like a deep philosophical question that you just hit. In this new world that we're all in, who's a developer? I mean, I've been writing code using take your pick LLM or coding tool. I mean, whether it's vibe coding or whether it's just generating code and then debugging with the LLM and having it behave like a two in a box copilot of some sorts. Uh, it doesn't matter. I mean, all of us.
But I mean, that's part of the answer to the question, and that is that if I'm building something that uses agents, this is a library that I can incorporate into what I'm building, as opposed to like this is enterprise infrastructure that someone in IT needs to stand up so that I can use it.
That's right. So it's as simple as leveraging those code snippets, two lines in your code. And again, given that we're all, it's turtles all the way down. So when you're building agents, these are all multi-agent apps. Jarvis, the app that we built for SREs, it's 20 agents within Jarvis, but Jarvis itself is an agent. So it's recursive in nature. Jarvis an agent. You have 20 agents plus inside it. An SRE is writing that code, or a bunch of SREs are in the organization. But then all of these other individual agents have been written by different developers. So whether it's a lowly manager here who's writing code, Vijoy, or it's an SRE, or it's a SWE, it doesn't matter. Like you can use the same process wherever in that hierarchy you sit, or whether it's a singular agent, it's accessing tools, or it's a multi-agent app that is being deployed or built by an IT organization.
And what kind of early feedback are you getting from folks?
So one of the use cases that we went after right off the bat is we have a bunch of partners that you'll see on the agency website that are deploying or building voice agents for customer support, as an example. And those are the use cases where this is like literally the best thing since sliced bread. We was trying to do voice interactions on gRPC is great to start out with, but you will not get the scale, the performance, the efficiency, and the security that you need. So those have been awesome. We want to go after now video agents and video capabilities as next step. But the deployers and the adopters per se are the ones that are jumping up and down saying this is pretty awesome.
What does your roadmap look like? Where are you heading with it, or what are your early users asking you to build next?
So I think on the agency front, the roadmap is primarily we launched all of those components of discover, compose, deploy, evaluate. And there are open source projects in all of those. But what we are looking for is and within those, there are different levels of maturity. So the directory is pretty mature, Slim is pretty mature, ACP is pretty mature, but we're also working with other uh, communication, syntactic communication providers. And then we are just starting out on some of the other pieces. So, identity, we just announced something recently, but there's a big roadmap there. So, there's a roadmap on all of those fronts, but I think identity evaluation are the next two big pieces. But I would say, in general, the ask to the community, to the listeners here would be come and join the work group calls, look at the GitHub, deploy it, play with it, give us feedback, even from the deployment perspective. And then if you're interested, there's so many places that you can contribute. Like just jump in and start contributing because it's not just a simple matter of communication. It's building out the entire framework of discover to evaluate that we're looking at. And things are, like I said, we are just starting out. This is the starting line. Things will get really gnarly over time. So we we have to think of it from a robust stack perspective and just think of all the problems that you need to go through to make this truly deployable in a large scale enterprise.
Well, Vijoy, thanks so much for jumping on and sharing a bit about Agntcy and kind of your vision for the Internet of Agents.
Thank you so much, Sam. It's been an amazing conversation.
It's been a pleasure. Thank you.